In Activity 3, Series and Parallel Batteries, students are introduced to series and parallel battery arrangements in circuits. They first build circuits in which the batteries are connected in series, and then construct circuits in which the batteries are connected in parallel. Students finally compare the brightness of bulbs in these two circuits. You will need the following materials from the kit: Activity Sheet 3, D-cell batteries, battery holders, number 48 flashlight bulbs, bulb holders, electrical clips, 15 centimeters insulated copper wire, a roll of insulated copper wire, and wire cutters. To prepare for the activity, make a copy of Activity Sheet 3 for each student. Cut and strip the ends from 4 new 15 centimeter pieces of insulated copper wire for each team. Each team of 2 will need 4 batteries, 4 battery holders, 8 electrical clips, 1 bulb holder, and 8 pieces of wire. To begin the activity, remind students of how they made a circuit that contained more than one battery. They should recall that they wired batteries from the negative terminal of one battery to the positive terminal of the other battery. Assemble a 2-battery, 1-bulb circuit in which the batteries are wired negative terminal to positive. Make sure to screw the bulb part way into its socket so that it does not make contact with the metal on the bulb holder. Inform students that when batteries are connected negative terminal to positive terminal, as in your demonstration circuit, the batteries are wired in a series circuit. Then, have the class help you trace the path of the electric current through the circuit. Encourage students to recognize that when the batteries are wired in series, a single current loop passes through all of the circuit elements. Ask students, what is another way that 2 batteries could be connected in a circuit? Accept all ideas, then inform the class that when batteries are connected negative terminal to negative terminal and positive terminal to positive terminal, the batteries are said to be wired in a parallel circuit. Using student suggestions, assemble a 2-battery, 1-bulb circuit in which the batteries are wired in parallel. Again, screw the bulb partway into its socket. Make sure to point out the 4th piece of wire used in making this parallel circuit. Note that students should not wire the batteries negative to positive and positive to negative when assembling their circuits. This will not only drain the batteries, but could cause the wires to overheat and possibly burn students. Again, have students help you trace the path of the electric current through the demonstration parallel circuit. Explain that in a parallel circuit, each of the batteries is connected to the bulb independently, so you will trace not 1 but 2 loops in this circuit. Trace the first loop from the negative terminal of the bottom battery through the wire and bulb and back to the positive terminal of the bottom battery. Then, trace the second loop from the negative terminal of the top battery, passing the negative terminal of the bottom battery through the wire and bulb, passing the positive terminal of the bottom battery, and back to the positive terminal of the top battery. Solicit suggestions from the class as to how to draw the series and the parallel circuit diagrams and label each diagram. Make sure students understand that the same basic circuit parts are used in each circuit, but the arrangement of the parts is different in the 2 types of circuits. Ask students, do you think that there will be a difference in the brightness of the bulbs in these 2 circuits? Accept all ideas, then inform students that they will compare the brightness of bulbs in series and parallel circuits. Next, distribute the materials in Activity Sheet 3 to students. Instruct students to complete the activity sheet and remind them to record their predictions and observations. Ask students, did you notice a difference in the brightness of the bulb when the batteries were connected in series and when they were connected in parallel? Students should respond that the bulb was brighter when the batteries were connected in series. Explain to students that the strength of batteries is measured in volts and that the batteries in the kit are 1.5 volts each. When batteries are wired in series, the strengths of the batteries are joined together and act like a single stronger battery. Refer to the circuit diagram of 2 batteries wired in series. Write 1.5 volts next to each battery symbol, add them, and write 3 volts to show students that the strength of the batteries is now 3 volts. Ask students, what happens when you wire more than 2 batteries in series? Explain that when more batteries are wired together in series, the strengths of all the batteries are joined together. Help students understand that if either battery wired in series is disconnected from the circuit becomes an open circuit and the bulb does not glow. Explain that circuits in which the batteries are wired in parallel act differently. If one battery is disconnected from the other, the bulb still glows. Since each of the two batteries is connected to the bulb independently, one closed circuit remains even when the other is opened. Another difference is that the bulb is not as bright in the parallel circuit as it was in the series circuit. Although both batteries are connected to the bulb, only a single current loop passes through both batteries. Therefore, the bulb only receives 1.5 volts. Batteries wired in series make a stronger battery, but batteries wired in parallel provide power over a longer period of time. Then, ask students, if you needed the brightest light from a bulb, would you wire the batteries in the circuit in series or in parallel? Students should say that the series circuit would produce the brightest light. Then ask, how would you wire the circuit if you wanted the bulb to stay lit for a long time, but did not need it to be very bright? Students should respond that a parallel circuit would stay lit for a long time. Finally, inform students that in the next activity, they will build more series and parallel circuits. To conclude the activity, have students return all batteries, battery holders, electrical clips, bulbs, bulb holders, and wires to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.